Welcome back. We're looking at section 6.2 today, some initial value problems with substitution. We've already looked at initial value problems. We've already looked at substitution, so we're just going to kind of blend those two topics together. Remember, initial value problems allow us to find that C value for a function after we've integrated it. So we're going to be given the derivative, we're going to be given some information about the original function, and we're going to be able to find all of that original function, including that C value. So we just have a couple of examples today, real nice and quick and short. Example 1 here, we have f prime of x is going to give us 3 times the quantity 2x minus 5 to the fourth. We want to find f of x if we know that f of 0 equals 2. Remember that f of 0 equals 2 is going to tell us that point is going to be 0, 2. So our x value is 0 and our y value is 2 for the original function. So how are we going to tackle the problem? Well, in order to get from the first derivative to f of x, we have to integrate. So we're going to integrate 3 times 2x minus 5 to the fourth dx. I could take 2x minus 5 to the fourth, multiply it out if I want. Remember, we have Blaise Pascal's triangle. He's going to allow us to multiply it out, or we can come up to the side and do a little u substitution. If we let u be that 2x minus 5, du then would be 2 dx's. We can't use the 2 dx's. We have a 3 dx in our original integrand. So we're going to divide both sides by 2 and end up with a 1/2 du equals a dx. We're going to take this 1/2 du into our integrand. So we're going to have the integration of 3/2 u to the fourth du. Now we can go and integrate. U to the fourth integrated is u to the fifth over 5. We're going to multiply 2 by the 5, and we'll end up with 3 u to the fifth over 10 plus c. If you don't like that coming off to the side, we had 3/2 times u to the fifth over 5. That's where our 2 times 5 gives us our 10. And remember, that's f of x. Well, we have to replace those u's with 2x minus 5. So f of x is 3/10 of 2x minus 5 to the fifth plus c. I can go ahead and replace then my x value with 0 and my y value with 2. So I'm going to have 2 equals 3/10 of, replacing my 0 with x, 2 times 0 is 0, minus 5 gives us negative 5 to the fifth plus c. I can go ahead and solve for my c value, negative 5 to the fifth. So we have 2 equals 3/10 of 31/25. Since we have a negative 5 to the fifth, it's going to be a negative 31/25 plus c. I can go and multiply my 10 over to my 2. I'm going to divide that by 3 and then divide it by my 31/25. And if I want to go ahead and do the fractional value of that, I end up with, I'm running out of some room here. We'll come off to the side here. 4 over 1875 is going to equal c. So my original function, f of x, is going to equal 3/10 of 2x minus 5 to the fifth plus 4 over 1875. That should be a negative, so minus 4. So our c value is a negative up there as well. That kind of messy, kind of scrunchy there. Example 2, we'll try to space out a little better. So here, we're going to integrate 3e to the 2x dx. We can't integrate e unless it's a single variable. So we're going to let our u equal that exponent. So u equals 2x. du then is going to equal 2 dx. Again, I can't use the 2, so I'm going to divide it over. So 1/2 du equals dx. Now I'm looking at the integration of 3 over 2 e to the u du. Integrating e to a single variable gives us e to that single variable. So our original function is 3/2 e to the 2x plus c. that gives us our f of x. But we know that f of 0 equals e. So when I replace my x with 0, I end up with e as my value, my y value. So e equals 3/2 e to the 2 times 0 plus c. E to the 2 times 0, well, 2 times 0 is 0, e to the 0 is 1. So we end up with e equals 3/2 plus c. Go ahead and subtract over our 3/2, so we end up with e minus 3/2 equals c. So our original function, f of x, is going to equal our 3/2 e to the 2x, and then plus e minus 3/2, which is our c value. From here, we can find a common denominator. We can clean it up however we want. On a quiz, I would probably ask you for a common denominator, which is going to be 2. So I end up with 3e to the 2x plus 2e minus 3 all over 2. And that allows us to find the original function, allows us to find that c value with our initial value problems. Happy integrating!